Right now, as you are watching this, the planet is running the hottest it has ever run in recorded human history. Not the hottest in recent memory, not the hottest in a generation. The hottest in the entire span of time that human beings have been measuring temperature with scientific instruments. And what scientists confirmed this week is not just another data point in a long and familiar trend. It is a threshold crossing that changes the risk calculation for billions of people simultaneously on every populated continent at the same time. The European continent is buried under the worst heat event ever documented in its history. 9,900 people are already confirmed dead, and that number is still climbing. Germany broke its national temperature record. Spain hit 45 degrees Celsius. France recorded its hottest day since records began in 1947. Belgium buried one exocyclone at 50 people in 2 weeks, the deadliest heat wave the country has seen in 30 years. Wildfires are burning right now from Portugal through Spain and into southern France with smoke plumes visible from space. And the heat dome producing all of this is not breaking, it is reloading. And Europe is not where the most dangerous part of this story is unfolding. Because at the same time that Western Europe is melting, India's northern states are recording temperatures above 50 degrees Celsius. The Persian Gulf is crossing wet bulb temperature readings that human beings cannot physiologically survive. The world's oceans are running at the highest average surface temperatures ever recorded in all of scientific history. And the Copernicus Climate Change Service, Europe's authoritative climate monitoring body, confirmed this month that June of 2026 was the second hottest June in recorded history, with a global average surface temperature sitting 39 degrees Celsius above pre-industrial levels. That number, 39 degrees, is not just a statistic on a report that gets filed and forgotten. It is the measured distance between the world as it existed across all of human civilization and the world that human industrial activity has now constructed. And what scientists are confirming this week is that the architecture of heat we have built into the atmosphere is no longer producing isolated events that break records in one country at a time. It is producing simultaneous, multi-continental heat emergencies that are overwhelming human systems faster than any prepared response can reach them. Today, I'm going to walk you through exactly what is happening and why it matters enormously that it is happening everywhere at once. We are going to look at the European catastrophe in full detail. We are going to go to South Asia and the Middle East, where the heat is crossing boundaries that are no longer theoretical. We are going to look at what the oceans are telling us right now, because the oceans are keeping a ledger of this crisis that is in some ways more alarming than any single land temperature reading. We are going to explain the wet bulb temperature threshold, which is one of the most important concepts in modern climate science, and one that almost no general news coverage ever takes the time to explain properly. And we are going to be direct about what all of this means in practical terms for every person watching this from wherever on this planet they are sitting right now. No guessing, no dramatizing, just the facts, the science, and the real stakes of what is confirmed and happening right now. Before we go any further, I want to ask you something directly. Where in the world are you watching this from? And has this summer already felt different to you in a way that is hard to describe, but impossible to ignore? A heat that arrives earlier in the season, lingers longer into the night, sits heavier in the air when the sun goes down? I'm not asking for a weather complaint. I'm asking because people watching this channel from dozens of countries are describing the same experience independently of each other, and that convergence of personal testimony across geography is one of the most important signals in this entire story. Drop your location and what this summer has felt like where you are in the comments right now. I want to read every single one of them. If you're not subscribed yet, right now is exactly the moment to do it. This channel exists to explain what is actually happening at the intersection of planetary science and human consequence, and every week that intersection becomes more urgent to understand. Subscribe right now, it is completely free. Turn on notifications, and if this video puts something in your understanding that was not there before, a thumbs up tells the algorithm to show it to someone else who needs to see it. Let us go for 5,000 likes on this one. Now let us get into it. Let me start with what the scientists actually confirmed and why the language coming out of the scientific community this week sounds different from what they have said in previous summers. Because there is a tendency in how heat coverage gets processed in news cycles to treat every new record as interchangeable with every previous record. A number goes up, a record breaks, a news story runs for a day or two, and then attention shifts elsewhere. What is different right now is not only the number itself, it is the structure of what is producing the number, and the structure is telling scientists something that has shifted how they are talking about what comes next. The Copernicus Climate Change Service, which is the gold standard for global temperature monitoring in Europe, and one of the most respected climate data institutions in the world, confirmed that June 2026 was the second warmest June globally since systematic temperature records began. The global average surface temperature for the month ran 39 degrees Celsius above pre-industrial levels. To understand why that number carries the weight that it does, you have to understand what pre-industrial means in this context. The baseline against which all modern temperature anomalies are measured is the average global temperature from 1850 to 1900, the period before large-scale fossil fuel combustion began fundamentally altering the composition of the atmosphere. Every fraction of a degree above that baseline represents an immense quantity of additional heat energy trapped in the Earth's climate system, energy that has to go somewhere, and it is going into exactly what we are watching unfold right now across multiple continents simultaneously. The Paris Agreement, signed in 2015 by nearly every nation on Earth, set a target of limiting long-term warming to 5 degrees Celsius above pre-industrial levels. The scientific rationale for that specific number was not arbitrary. Climate researchers established through extensive modeling that beyond the 1.5 degree threshold, the frequency and intensity of extreme heat events, droughts, floods, and major storms would escalate in ways that would become increasingly difficult for human societies to manage and adapt to. We are sitting at 139 degrees right now in the middle of summer, with the hottest months of the year still running their course across the northern hemisphere. And here is the dimension of this that a single monthly average does not fully communicate. The year 2024 was the first full calendar year in recorded history to average more than 1. 5 degrees of warming above pre-industrial levels across all 12 months combined. We crossed that threshold as a full year average just 18 months ago. The trajectory since then has not shown signs of reversing. The structural conditions of the global climate system that are producing these temperatures are not an anomaly that will self-correct. They represent a new and still rising baseline on top of which all weather events now operate. The extreme events we are watching this summer are not being generated by an unusually strange atmosphere. They are being generated by an atmosphere that is doing exactly what physics dictates it will do when it contains this much additional heat energy. What is happening in Europe right now is the most immediately visible illustration of that shift, and it deserves to be understood in its full scale because the numbers coming out of the continent are extraordinary, even by the standards of the last several years of record-breaking summers. Since approximately June 20th of this year, a massive dome of high pressure has been positioned over Western and Central Europe, and it has not moved. High-pressure systems function as atmospheric caps. They suppress cloud formation. They prevent rainfall. They compress and heat the air trapped beneath them through a process called adiabatic warming, where descending air heats as it is compressed by the weight of the atmosphere above it. Once a strong high-pressure system locks into position over a continent in summer, it can maintain itself for weeks at a time, transforming what might have been a warm spell into a prolonged and lethal emergency. This particular dome has been drawing air directly from the Sahara Desert northward across the Mediterranean and pushing it deep into the geographic interior of Europe, day after day, without meaningful interruption. The temperatures resulting from this pattern are not merely warm, they are staggering in their departure from anything these regions have historically recorded. France, Spain, and Portugal have been running 12 to 16 degrees Celsius above what is considered normal for mid-July. That is not 2 degrees above normal, not 5 degrees. 12 to 16 degrees above the historical average for what the calendar says these places should be experiencing. Germany reached 41, 7 degrees Celsius on June 28th, a provisional new national record that broke the previous mark that had stood for years. Spain recorded 45, 1 degree Celsius. France is approaching 45 degrees in the days ahead. Hungary broke its national temperature record. The United Kingdom broke its all-time record for its hottest June day on 3 consecutive days in a row, a sequence so improbable under any previous understanding of British climate that meteorologists initially struggled to process what they were seeing in the models before it happened. These are not incremental record adjustments. In normal climate variability, temperature records are broken by fractions of a degree after standing for decades. When a country breaks its all-time temperature record by more than a full degree, it is not registering an unusually hot summer. It is registering the arrival of a new range of possible temperatures that the atmosphere above that country is now capable of producing. The human cost of this pattern is already catastrophic, and it is still accumulating. Belgium recorded 1,747 excess deaths between June 18th and July 1st, a period of just 2 weeks. Excess deaths is a specific statistical methodology, and understanding it is important for grasping what heat actually costs in human terms. It measures deaths above and beyond what predictive models would expect for that same period based on historical baselines. It does not require a death certificate to say heat was the cause. It captures everyone who died when they statistically should not have, regardless of what mechanism the heat used to kill them. The excess mortality rate in Belgium during the peak of this event was 39%. 39% more people died than should have died. These were not exclusively elderly people in nursing facilities, though elderly people are without question the most physiologically vulnerable to sustained heat. They were people across age groups and across regions, many dying in their own homes from mechanisms that heat uses to kill quietly and invisibly. Cardiovascular stress pushed past the threshold by the metabolic demand of thermoregulation. Kidney failure driven by dehydration that progressed past the point of self-correction. Respiratory failure in people whose pulmonary function was already reduced by other conditions and could not handle the additional strain. Heat takes lives through mechanisms that are medically real, medically preventable, and frequently not recorded as heat-related in official cause of death statistics. The excess mortality methodology is the honest accounting for what heat actually costs. Across Europe as a whole, excess mortality estimates from this event are running above 9,900 people. And that number will continue rising as data from the ongoing July phase comes in because the heat dome is not breaking. It is repositioning and re-strengthening. The wildfire dimension of this crisis runs alongside the mortality data and compounds it in ways that add urgency beyond the immediate death toll. Fires are burning right now from Portugal across Spain and into southern France. The smoke from these fires is visible in orbital satellite imagery. Fire behavior under the conditions Europe is experiencing, temperatures above 40 degrees Celsius combined with critically dry vegetation that has received almost no meaningful rainfall in weeks, and the strong directional winds generated by the pressure gradient at the edge of the heat dome becomes extraordinarily dangerous and resistant to containment. The firefighters working the fire lines in Portugal and Spain and France right now are operating in conditions where the fire can outrun vehicles, where wind shifts occur in minutes without warning, and where ground that appeared extinguished can reignite from residual heat within hours if conditions remain as dry as they are. The drought running underneath and alongside the heat emergency is a dimension of this crisis that does not make as much immediate news as the death tolls, but will have consequences that outlast the heat dome by years. The 30-day precipitation outlook for France, Spain, Portugal, the United Kingdom, Germany, and the Netherlands shows significantly drier than normal conditions, extending through July and into August. The soil moisture deficits that have accumulated across these agricultural regions are not going to be repaired by the scattered convective storms that might briefly appear at the edges of the system. They require sustained, widespread, gentle rainfall over multiple weeks, and that is not in any credible forecast model for the near term. Farmers watching their fields in southern France and central Spain right now are watching yields that were already stressed by the heat deteriorate further with each additional dry, scorching day. But as serious and as deadly as Europe's crisis is, it is not the place on this planet where the heat is closest to crossing the absolute boundary of what human physiology can tolerate. For that, you have to look at South Asia and the Middle East, and you have to understand a concept that most general news coverage never explains, called wet bulb temperature. Most of us think about heat in terms of air temperature. The thermometer reads a number, and that number tells us how hot it is. But the human body does not regulate its core temperature with thermometers. It regulates it through sweating, and the effectiveness of sweating as a cooling mechanism depends not on air temperature alone, but on the simultaneous combination of air temperature and relative humidity. When the air is dry, sweat evaporates efficiently from the skin surface, carrying heat energy away from the body with it as it converts from liquid to vapor. This is why a 42-degree day in a low-humidity desert environment can be survived with appropriate hydration and shade, while a 34-degree day in a high-humidity coastal environment can feel overwhelming. The desert air is absorbing and removing sweat. The humid air cannot. Wet bulb temperature is the measurement that captures this combined physiological reality. It is the temperature reached by a surface that is fully saturated with water and exposed to the ambient air. It integrates both heat and humidity into a single number that tells you not how hot the air is, but how effectively the human body can shed heat into it. A wet bulb temperature of 35 degrees Celsius represents the absolute physiological ceiling for human survival. At a wet bulb reading of 35 degrees, a young, healthy adult sitting completely still in full shade with unlimited access to water cannot remove heat from their body as fast as the environment is adding it. Core body temperature rises regardless of hydration. Hyperthermia develops. Death follows within hours. For the elderly, for children, for pregnant women, for anyone with cardiovascular or respiratory compromise, the effective survivability threshold is substantially lower than 35 degrees wet bulb. For decades, climate scientists treated wet bulb temperatures of 35 degrees Celsius as a theoretical future projection, something that might occur under severe warming scenarios later in the century, not something observable in the current atmosphere. Research published in peer-reviewed journals, including Science Advances, has now documented that those wet bulb readings have already been reached, briefly but measurably, in real atmospheric observations at locations including the coast of the Persian Gulf, the Indus Valley in Pakistan, and parts of the northwestern Indian subcontinent. The events have been short in duration, lasting hours rather than days, but they have been recorded in actual measurements, not model outputs. The survivability boundary of the human body is no longer a scenario that future generations will have to confront. It has already been temporarily crossed in regions where real people live. What makes the Persian Gulf and surrounding areas particularly dangerous in the current heat pattern is the population of outdoor workers, overwhelmingly migrant laborers in construction, agriculture, and logistics, who do not have the legal or economic authority to stop working when conditions become physiologically threatening. When wet bulb temperatures approach the human survivability limit, the only protection available is removing a person from the environment. There is no hydration strategy, no cooling vest technology, no scheduling adjustment that substitutes for getting a person out of air that their body cannot shed heat into. For workers who cannot leave, the physiology does not negotiate. The body fails on the timeline that the heat and humidity dictate. India's exposure in the current pattern is severe in a different dimensional structure. The northern states of Rajasthan, Uttar Pradesh, and Bihar have recorded air temperatures above 48 degrees Celsius in repeated events this summer. India's population of 4 billion people includes hundreds of millions of households, where air conditioning is entirely inaccessible, where the mitigation strategy available to a family in extreme heat is to close shutters, stay inside, and wait for the temperature to drop overnight, enough for the body to recover from the day's accumulated thermal stress. But the overnight recovery window has been failing in the current pattern across much of South Asia, in the same way it is failing in Europe. When nighttime temperatures remain above 30 degrees Celsius, the body cannot complete the thermal recovery that makes the next day's heat survivable. After multiple consecutive nights of inadequate cooling, the accumulated physiological burden crosses critical thresholds. The populations most vulnerable are the ones whose bodies have the least capacity to sustain that burden. The agricultural consequence of what India is experiencing runs directly into global food security in ways that affect populations far beyond India's borders. Wheat crops in India's northern growing regions are acutely sensitive to temperature during the grain filling stage, the period when the plant is converting nutrients into grain mass. When temperatures exceed 35 degrees Celsius during this window, the process accelerates abnormally, and the grain does not develop fully. Yield losses of 20 to 30% in severely affected regions are not theoretical projections. They have been documented in multiple recent growing seasons when heat arrived at the critical phase. India is the world's second largest wheat producer. When its harvests are compromised by heat events, the downstream pressure on regional and global grain markets is felt across South Asia, the Middle East, and parts of Africa, where food import dependency makes the price signal from Indian production a direct factor in household food security. Heat that damages one country's fields migrates through global supply chains and appears as price increases in markets thousands of miles from where the crop failed. Now, I want to spend time on the oceans, because if there is one single metric in the entire global heat picture that is producing genuine alarm in the scientific community right now, it is not any specific land temperature reading. It is what the world's oceans have been doing for the past 18 months and what the measurements are showing about the rate and scale of that change. The world's oceans cover approximately 71% of Earth's surface area. They absorb roughly 90% of the excess heat that the accumulation of greenhouse gases in the atmosphere has been trapping in the climate system. This means that the oceans have been functioning as an enormous thermal buffer throughout the industrial era, absorbing the vast majority of the additional heat that would otherwise be expressing itself immediately and continuously on land surfaces and in the lower atmosphere. The ocean is a primary reason that land surface warming has been as gradual as it has been rather than more rapid. But that thermal buffering carries a cost that is now becoming visible in measurements that have left oceanographers struggling to find historical parallels. Global average ocean surface temperatures in 2023 and continuing into 2024 broke records by margins that scientists describe publicly as unprecedented and in some cases shocking. In the North Atlantic Ocean in the summer of 2023, sea surface temperatures ran in some areas more than 3 degrees Celsius above the seasonal average for that location, an anomaly so large and so geographically extensive that climate researchers found it extremely difficult to identify any previous period in the observational record to compare it to. The anomaly was not a localized patch of warm water. It was a sustained, large-scale departure from everything the ocean surface has done in the history of systematic measurement. The significance of elevated ocean surface temperatures for what we are experiencing on land right now is direct and cannot be understated. Warmer oceans moderate climate less effectively. When the ocean surface is already running significantly above its historical average, its capacity to absorb additional atmospheric heat from above is reduced. Heat that the ocean would under normal conditions pull downward from the lower atmosphere instead remains in the atmosphere. It expresses itself on land. The record-breaking land temperatures in Europe, the life-threatening heat in South Asia, the extreme wet bulb readings along the Persian Gulf coast, All of these land-based events are occurring in an atmosphere that is partly a consequence of oceans that are carrying more accumulated heat than at any point in recorded history and whose buffering capacity is operating under significant strain. There is a second consequence of elevated ocean temperatures that connects directly to the intensity and structure of weather events at a hemispheric scale. Warmer oceans evaporate more water into the atmosphere. More water vapor in the atmosphere means more energy available to weather systems of every type. It means more intense rainfall events when that moisture precipitates out. It means more intense tropical cyclones because tropical cyclones are fundamentally heat engines powered by ocean surface warmth. And it means heat events with more persistently elevated overnight temperatures, because increased atmospheric moisture content raises dew points and acts as an insulating blanket that prevents the overnight radiational cooling that would otherwise moderate how dangerous a daytime heat event becomes. When people in France, Belgium, Germany, and the Netherlands describe nights where the temperature barely drops below 27 or 28 degrees and sleep is genuinely impossible, they are describing the fingerprint of elevated atmospheric dew points combined with a blocking high pressure system. Those elevated dew points are connected to the elevated ocean temperatures that set records last year. The events are not separate phenomena. They are linked components of a system in which more energy everywhere produces more extreme outcomes everywhere simultaneously. The marine ecosystem consequences of sustained ocean warming run alongside the human story, and they deserve to be stated because they feed back into human food security on a scale that most general coverage misses. The Great Barrier Reef, covering approximately 344,000 square kilometers and hosting one of the most biodiverse ecosystems on Earth, has experienced repeated mass bleaching events driven by elevated sea surface temperatures. Coral bleaching is triggered when ocean temperatures rise even 1 degree Celsius above the thermal tolerance threshold that the coral's physiology is adapted to. The coral expels the symbiotic algae living in its tissue, the algae that provide both its color and up to 90% of its energy through photosynthesis. The coral whitens. If elevated temperatures persist for weeks, the coral dies. Recovery from mass bleaching events is measured in decades under optimistic conditions. For severely affected areas, recovery on any meaningful human time frame is not guaranteed. Coral reef ecosystems provide food security for an estimated 1 billion people globally, concentrated in coastal and island communities across the Pacific Ocean, the Indian Ocean, and the Caribbean. The degradation of those ecosystems does not stay in the ocean. It moves directly into the protein supply of populations that depend on reef fish as their primary source of food. I want to make sure we address the question that I know a significant portion of people watching this are asking, whether silently or in the comments, because it is the question that derails the most important conversations about this topic. Is this natural or is it human-caused? And I want to be direct with you. The framing of that question is itself the problem, and understanding why is essential to understanding what we are actually dealing with. The Earth's climate has always had variability, hot years and cold years, wet decades and dry decades, El Niño patterns that warm the Pacific and shift rainfall patterns across the planet, La Niña patterns that produce the opposite effect. None of that variability has gone away. Weather is still variable. The atmosphere still produces heat waves and cold snaps through the same physical mechanisms it always has. What has changed is the baseline temperature sitting underneath that variability. Think of it as follows. Natural climate variability is like a dice roll. Sometimes you roll high, sometimes you roll low. Random, variable, expected. Climate change from accumulated greenhouse gas emissions is like loading the dice so that, on average, they roll higher. Every individual roll is still the dice doing their random thing, but the average outcome has shifted upward. And the extreme outcomes, the very high rolls that under the old probability distribution happened perhaps once a century, now happen far more frequently because the entire probability distribution has shifted. Attribution science, the field of climate research that quantifies how much more likely specific extreme events are in a warmed world compared to a pre-industrial one, has made enormous advances in the past decade. The European heatwave of 2003 that killed an estimated 70,000 people across the continent was assessed by researchers as having been made approximately twice as likely by human-caused climate change at the time it occurred. More recent European heat events have been found in peer-reviewed attribution analyses to be up to 5 times more likely in today's climate than they would have been in a pre-industrial baseline world. The loading of the dice is not uniform. As the baseline continues rising, the multiplier on the probability of extreme heat events rises with it. What no credible voice in the scientific community is claiming is that any of this is reversible in a time frame that matters for the people alive today. The greenhouse gases already accumulated in the atmosphere will continue influencing temperatures for decades, even if all emissions stop completely tomorrow, which they have not and will not in the near term. The ocean heat already stored will continue modifying atmospheric patterns and temperatures for decades because oceanic thermal systems operate on much longer timescales than human policy cycles. The trajectory that has produced 1. 39 degrees of warming above pre-industrial baseline is a trajectory that the next several decades will continue to follow regardless of what happens in the short term. The question that actually matters for people alive right now, for policymakers, for city planners, for hospital administrators, for ordinary families making decisions about where to live and how to prepare, is not whether the warming trajectory reverses in the next few years. It is what human systems can be built to survive what the trajectory is going to deliver. And that question produces the same answer every time you examine the evidence clearly. The death toll from heat is not determined by what the thermometer reads. It is determined by what human beings built and how well they prepared before the thermometer hit that reading. The 2003 European heatwave, which killed approximately 15,000 people in France alone in 2 weeks, forced a genuine rethinking of how governments across Europe prepared for extreme heat. France in particular underwent a systematic restructuring of its heat emergency response infrastructure after 2003. Heat health warning systems were established with defined temperature thresholds that trigger specific government responses automatically. Formal systems for proactively checking on elderly people living alone were developed and funded at the local authority level. Public cooling centers were identified, stocked, and communicated. Outdoor workers received legally mandated cooling breaks above temperature thresholds. Healthcare systems developed protocols specifically for managing mass heat illness in a way that had simply not existed before. None of these are technological innovations that require decades to develop. They are organizational decisions that require commitment, coordination, and sustained funding. The result of France's investment in those systems is measurable in subsequent events. Heat waves that have struck France in years since 2003 with comparable or even higher temperatures have produced significantly lower excess mortality per degree of temperature anomaly than the 2003 event produced. The preparation worked. It does not eliminate heat mortality because no system can completely prevent deaths from extreme heat in a vulnerable population. But it measurably reduces the death toll relative to what unpreparedness produces. Japan has maintained heat health action plans for years that include an extensive network of publicly designated cooling shelters, which are official public spaces with effective cooling that anyone can access during extreme heat events without cost. Public communication in Japan during heat emergencies is specific, repeated, and taken seriously by a population that has been consistently educated about heat risk. The result in mortality statistics is visible in comparisons between Japan and countries with equivalent heat exposure but less developed response infrastructure. Ahmedabad in India developed one of the world's first comprehensive city-level heat action plans after a devastating heat event in 2010. Peer-reviewed research analyzing the plan's impact found measurable reductions in heat mortality in subsequent events when comparable temperatures struck. A plan developed in a middle-income city in India, applied consistently, reduced the death toll from extreme heat. The science of what works is not unclear. The gap between knowing what works and implementing it at the scale the current heat crisis demands is the gap that is producing thousands of preventable deaths right now. Let me close with what you can actually do with all of this information, wherever you are watching from, because I have spent a great deal of this video describing what is happening and why, and I refuse to leave you only with the weight of it without anything actionable to carry with you. If you are currently in Europe, South Asia, the Middle East, or any region experiencing the conditions I have described, the practical reality of extreme heat demands specific behavior rather than general caution. Heat kills through mechanisms that are physiologically real and in most cases entirely preventable with the right information applied at the right time. Stay hydrated continuously, not reactively. By the time thirst registers as a sensation, mild dehydration is already underway, and the cardiovascular system is already under additional strain from the thermoregulatory demand. Drink water before you feel thirsty. Drink it consistently throughout the day. The hours between approximately 11 in the morning and 5 in the afternoon represent the window of peak solar radiation intensity and peak air temperature. Limiting outdoor exposure during those hours is not excessive caution in the conditions we are currently describing across large parts of the planet. It is the single behavioral change most directly connected to survival outcomes. The people most at risk around you are frequently not the ones who will tell you they are in distress. Elderly neighbors who live alone will not call for help when they are becoming dangerously overheated. Young children will not voluntarily stop playing outside in conditions that are dangerous for their smaller bodies and less efficient thermoregulation. People with cognitive impairments cannot reliably self-assess their physiological state. A phone call to a neighbor you have not heard from in 2 days during a heat wave is not an intrusion. It is potentially life-saving. A bottle of water given to someone you see working outdoors without shade or cooling is not a small gesture in conditions like the ones being recorded right now. These human-to-human actions fill the gaps that no government emergency system reaches completely. Know where your local cooling centers are before the peak of the next heat event arrives. Libraries, community centers, shopping centers, and officially designated public buildings with functioning air conditioning are available in many cities as formal cooling resources during extreme heat emergencies. Find out where yours are now while you're not yet overheated and struggling to think clearly, so the information is accessible the moment you or someone near you needs it. If you are a local official, a city planner, a hospital administrator, or anyone with responsibility for public systems in a region where summer temperatures are becoming structurally higher than the infrastructure was designed to handle, the confirmation from scientists this week is a mandate. Heat health action plans work. The evidence base across France, Japan, India, Spain, and multiple other contexts is clear. The investment required to build and maintain them is a fraction of the economic and human cost of the mortality events and healthcare system strain that happen without them. The planet is one. 39 degrees warmer than the world that every civilization in human history before ours was built in and adapted to. The trajectory of that number is not reversing on timescales relevant to any living person. The summers ahead will run at baselines above the ones we are navigating right now. The extreme events that sit on top of those baselines will be more frequent and more intense than the events being documented this summer. That is not speculation. It is what the physics of a system with more accumulated energy in it than at any point in human history dictates. What Japan proved to the world about earthquake disasters applies here with equal force. The casualty count of a natural event is the physical event combined with the human decisions made before it arrives. Venezuela showed the world what happens when a 7.5 magnitude earthquake meets a population that was not prepared and buildings that were not designed to survive. Japan showed what happens when a society takes its geological reality seriously across decades and builds accordingly. The societies that will navigate the heat decades ahead with the lowest human cost are the ones making different decisions right now. Building urban tree canopy at scale to reduce pavement temperature in cities, designing buildings that maintain livable temperatures without mechanical cooling, expanding the healthcare infrastructure specifically for heat-related illness, and building the social systems that reach the most vulnerable people proactively, rather than after the mortality is already accumulating. The global heat crisis has confirmed this week that it has reached a terrifying new level. The 9,900 people already dead in Europe this summer are not an abstraction at the end of a data report. They are the consequence of a world that is warmer than any previous human generation has had to live in, falling on systems that have not yet fully reckoned with what that means. The number will keep changing as data comes in from the ongoing event. The temperatures will keep being monitored. The oceans will keep holding their ledger. And the gap between what the atmosphere is now capable of delivering and what our cities and our infrastructure and our emergency systems are built to absorb will keep being the variable that determines who survives and who does not. We will keep tracking all of it, every record that breaks, every excess mortality report that comes in, every shift in the forecast models showing where the next dome builds and which populations are in its path. Subscribe so you do not miss a single update. Leave that comment below telling me where you're watching from and what this summer has felt like where you are, because this is not a story that lives only in data. It is a story about billions of human beings on a planet that is changing faster than the systems built to protect them are adapting. And every voice from every place this is happening adds something real to our collective understanding of what we are all living through together. Get this to 5,000 likes. Help the algorithm put this in front of the people who need the information before the peak of the next event arrives. Share it with someone in a heat-affected region who needs to understand what is happening and what to do about it. See you in the next one.